Hello and welcome to the next episode of 3D30. This is our first one for 2023. So welcome to the first show of the new or of the year of the new year, but it's not really the new year anymore. 3D30 is Velo3D's LinkedIn Live and YouTube Live channel, and we host this about every 2 weeks. This is becoming a very slippery schedule, but we do have one in 2 weeks from now. So make sure you follow us on Velo3D and LinkedIn to get that schedule, because we tend to change it a lot. So stay tuned to our LinkedIn channel. Make sure you follow us for that. You know, a lot of metal 3D printing, and we're going to be talking about metal 3D printing, of course, that's what we talk about, has been kind of developed under the assumption that a bespoke artisan solution is what customers need. And that's kind of the direction that the industry's been going. And for about 30 years now, it's led to growth and it's led to some proof points. But at Velo3D, we're sort of banging our head against the wall. We're like, there's got to be a bigger market out there. You look at the metal manufacturing market, and metal additive manufacturing is like 1% of the whole market. So it's obvious that there's something else out there. There's a much larger market out there. And in preparing for this session, I kind of went back to some of my book reading, business reading days. I was thinking about crossing the chasm, looked into that. And I found that there's actually a predecessor to Crossing the Chasm called Diffusion of Innovations. And this is an interesting work because it sort of lays down, and I've got a graph here, it lays down the elements that the author, Everett Rogers, feels important to move forward, to go from left to right in this graph. And there's 6 things here that he lists: is advantage, compatibility, complexity, trialability, which is hard to say, just testability, potential for reinvention, and observed effects. And if you look at the first 5, like those are really the things that you got to use to navigate. Observed effects you start to build over time, and that leads to momentum. It's perpetual. If I were to look at metal additive manufacturing, I would take the ones in green, and I would kind of give us an A plus here, right? Relative advantage. Additive is going to give you all this new advantage, new parts, potential for reinvention, absolutely A plus. But what about the red things? How complex is it as a technology, as a manufacturing technology? And I'd say that it's very complex. It's probably one of the lower grades that we would get on a report card. How easy is it to test? You might be able to get a form, fit, and function prototype part out there, but if you really want to test this for manufacturing, it's challenging. It is not easy. So I think if you look at that and you look at the context of diffusion of innovation, you say, where could we improve? It's those 2 areas. How can we make this less complicated? And then also, how can we get this so that it's more testable? So we're going to talk about that today. And we're going to welcome Brent Hansen. We're going to bring him on our show here. Hey, Brent, technical business development manager. And Brent has a lot of experience outside of Velo3D. So we're going to leverage his past experience in addition to his Velo3D experience. And we're going to start to answer this question, like, how do we move this forward? How do we get access to the big market? We're at 1% now. We want to be in the 99%. My name is Mike Roderson. I never introduced myself, but I'm going to start doing that this year. That's my New Year's resolution, to introduce myself on these shows. And today we're going to answer the question, is Velo3D's golden print file the Midas touch for 3D printing? So as a note, this is a live show and we want to hear from you. We do have a slight delay between when you ask a question and when we answer the question. But I see we already have one in the queue. So Brent, tell us about your background. I'm going to take a look at the questions that are in the queue while you do that. But I'd like for the audience to get to know you a little bit.
Yeah. Welcome, everybody. Thank you for joining. As Mike mentioned, my name is Brent Hansen. I come from a background in metal printing from a couple different companies. If we go way back to, I graduated school and got a job as a manufacturing engineer at Lockheed Martin Space Systems Company, and immediately noticed that we had just set up an additive lab at Lockheed. And I mentioned to my boss that I really wanted to get involved, and he got me, as every great manager should do for their employees, he got me involved in the lab that I requested. And I started writing work instructions and everything else for that lab. Eventually kind of took over the lab as the lead engineer. For various reasons, departed Lockheed and went to a spinal med device company that makes spinal implants called NuVasive. At NuVasive, I worked with a great team there to develop additively manufactured spinal fusion implants. Did that for a couple of years, launched a couple products, and had a great experience 3D printing for implants. And after that, I landed at General Atomics for a number of years. And at General Atomics, I was hired on as a metal additive manufacturing engineer, working to set up the metal printing department, and eventually just working on all things additive for them as a applications engineer, developing all sorts of super cool applications at General Atomics. And now I'm at Velo3D. I'm a technical business development manager, and I help a lot of different customers on the West Coast specifically with their technical developments as far as getting their parts ready to print and how to utilize our contract manufacturing network.
Awesome. And so we do have a question. I'm actually going to break this into two questions because I think it fits right into what we wanted to talk about today. The Mo asks, what challenges does Velo3D face in getting large EV companies to adopt AM? But I think we can broadly look at it and just, we'll take the EV out and we'll look at companies. So, what challenges are there in getting large companies to adopt additive? And then we'll look at the Velo side of that.
Yeah, so as far as the challenges of getting large companies to adopt, one is, in all things considered, it's a relatively new process. There's only been really a good solid 10 years of development in metal additive. There's been a couple companies that have been doing it for a little bit longer, but for the most part, it hasn't been that mainstream until the last 5 to 10 years. So some of those challenges are, one, it's you can't just pick up a metal machine and start printing parts and putting them into use, depending on your application. And that's one thing we'll talk about a little bit more as far as like the criticality of your parts and kind of what's required to move into production with metal additive. But understanding the business case and more importantly, making those initial investments to really set the process up to satisfy your needs. And that's not easy. It takes significant amounts of money for large companies to get metal printing departments up to speed, to really understand fully what you're printing and how that applies to your product. And that executive leadership, has to be on board. But
and when they do that, like they go through the effort, they build something. What does it look like when they build it? I mean, what's the state of that solution? Can it just do anything for any part?
Yeah. So to start, you always start with the business case, right? And make sure that business case applies. But then as far as like getting the part out of the printer, there's several post-processing steps involved to get your part to where it needs to be. And for the most part, metal laser powder bed fusion parts come out of the printer with a relatively rough surface finish. And it really takes people back. When they look at the surface roughness for the first time, and they're so used to like a 125 RA finish out of a machine shop, and they see this roughness on a metal 3D printed part with laser powder bed fusion, it's like an 80 grit sandpaper, right? And people aren't used to that. And so when you show that to executives and they say, oh, what's going on here? I don't want to deal with this. Too much post processing, stress risers, all sorts of different things that people might not be used to. It takes a mentality shift to understand, hey, we're not machining parts. We're trying to unlock all these new potentials for you to move into production with additional performance, lightweighting, combining assemblies, all those types of advantages that the industry has been preaching for a little bit now.
The ones that we get the A+ on.
Yeah.
and okay, so now I'm the CEO of a Fortune 500 company. We're gonna role play. I just built my additive lab. It's great. Cost me a lot of money. Now I'm looking to get my contract manufacturers involved. Can I just go to them and send them a file and get them to start printing, or what's that process look like?
Man, you're leading us straight into it for the topic of the day. So you just spend a couple $1 million to get your department set up. If you're lucky, it's only a couple million. For these Fortune 500 companies, right? I'm focusing specifically on what you're requesting here.
Well, that's what Mo asked, so we're gonna stick to Mo's question.
Yeah. So this isn't the same for every company, right? But we're talking your Fortune 500 without naming names. As soon as you develop your process internally, you can start making parts on your machines with your process spec, right? At this point, you should understand, exactly what you're asking for and what you're doing in your process to get to where you need to be. And as soon as you go into the traditional contract manufacturing network, and when I say the traditional ones, I mean the ones that have been around for a little while, who are using machines from any maker, most of the time they have developed a process that is specific for them. And so they have, their own process spec, right? So you send them your process spec, and they go and they compare theirs versus yours, and they see where they differ. They send that back to you with all these red lines, and you either have to, make adjustments to yours to fit what they're doing, or you have to tell them to change what they're doing to fit what you're doing. And a lot of times they have developed, anywhere you're trying to go into production, they've developed their own custom kind of solution to be better, faster, quicker, whatever it might be, than their competitors. And so what that drives is a whole bunch of NRE, so non-reoccurring expense, where you have to pay this facility to develop your part now that you want to go into production. You have to pay that facility when you want to go into production. And so the image shown here is exactly what I'm talking about. When you go to supplier one, you have to essentially do a whole bunch of NRE, spend a whole bunch of money to develop that part that you've already developed on your internal system, but that you might not be able to repeat on their system due to the way that they have tweaked it and tuned it to work perfectly for them. And then if you want to go to the second supplier, you got to do the same thing with them. And so as a Fortune 500 company, when you're really pushing the control of the process, it starts to become extremely challenging.
Okay, awesome. So it just reminds me of like going to a coffee store. It's like you have Starbucks, for lack of a better term. I know exactly how to order my coffee there. I go to like a local artisan coffee house. I try to order the same thing. It tastes different. It's too sweet. It's not sweet enough. It's like something, or it's not dark enough or whatever. It's just not the same. So that inconsistency, like when I travel, even though I might want a better coffee, I just kind of stick with what I know. It almost sounds like you're talking about like a franchise idea.
Yeah. So personally, I'm not much of a coffee drinker. I'm more of a pizza kind of guy. Spent a couple years in Italy, and I'm a big fan of pizza, right? And in Italy, it's the perfect example. If you go 20 miles and get a different pizza, each city has its own flavor of pizza. And just like additive solutions, right? If you order the same pizza at a different additive service bureau, you're going to get potentially a different thing. And there's a couple different reasons why that is. But at the end of the day, it's really not good for companies to have to go and essentially try to develop that same pizza over and over again at different facilities who have different ovens and different ingredients, right? To try to get to that solution that you want. And so, like you mentioned, that franchise is definitely the way to go. If you get a pizza from your favorite franchise in one city versus the next, it's pretty much going to taste the same.
So, don't want to take the analogy too far, but let's get it to AM specifically. How do we, I'm going to do it again, but how do you make the same pizza? How do we make the same parts in metal additive over and over? What is needed there? How do we accomplish that?
Yeah, don't worry. I'm okay talking about pizza all day too.
Making me hungry.
So really, it all comes down to ensuring that your process is repeatable and is the same. And in metal additive, the way to do that, that I strongly believe, the way to do that is by your ability to calibrate your machine, right? So at your non-franchise type of machine, you're going to take and calibrate that machine, give or take, once every 6 months. And it's a field service engineer who's doing that calibration. He's printing some coupons or taking some scans and then measuring those, right? And then adjusting exactly what he's seeing to ensure that that the machine is calibrated, right? At Velo3D, we take a different approach to that, where the machines effectively calibrate themselves. So with a handful of clicks on the screen, the sensors that are in the machine already are able to quickly and repeatably calibrate your system to ensure that repeatability is happening over and over and over again. And we'll get into a few reasons as to how this actually works and why this is relevant. But for the most part, that's allowing us to give you more that franchise approach, or democratizing metal additive manufacturing, and your ability to repeat your parts over and over again, regardless of where you're printing them, so long as they're running the same alloy.
Okay, I do want to jump in. Brian asked the question. You mentioned kind of the sandpaper on the parts. The parts are not like shiny, glassy, smooth.
Yep.
So Brian asks, how do you avoid cavitation problems caused by fluid dynamics against a rough part?
Mm-hmm. Yeah, so it all depends on your application, of course. But let's take a air intake on the outside of an airplane. There's a couple different things that you can do. One is you can run it through, your various finite element analysis or FEA solutions to see what kind of what that roughness is going to have an effect on as far as like what your fluid flow would be. But then there's a couple different post-processing techniques you can employ to improve that surface finish. So a lot of people will use a simple grit blast, a bead blast, a vapor hone, which is like a water-directed grit blast, or a chem etch. So there's a couple different relatively simple post-processes that you can apply, and the effectiveness depends on which alloy you're printing. One thing that I personally have found that works very quickly and very fast is just to paint it, right? If it's on a fluid flow surface, just hit it with some primer and ensure that you're getting what you need, and you can usually get what you're looking for pretty quick.
Nice. We actually did a session last year with, I believe the company was named with Kimion, and they have a purple primer, so you can visually tell the contrast between the purple and then your parts, and you can tell. And they deal with a lot of marine applications, so you're getting sort of that corrosion protection, and you're improving the flow dynamics. That's actually an interesting way to deal with it. I've heard everybody etching, abrasive flow control type of solutions, but painting, that's a new one. I'll have to add that in.
It works very, very well from personal experience.
That sounds awesome. So I did want to kind of come back. So we got our machines, we're calibrating them, but what effect is that then having on the part? Like, how is that making the parts more consistent, or like what's changing?
Yeah, so a couple different things here, but one where I would like to take the answer here is straight into the information that we're feeding the machine as far as like what you're attempting to print. So in a traditional world, for some of the legacy metal printers, when you import, and this applies to a lot of them, but not all of them, just as a caveat there, when you take your CAD file, you slice it, and so slicing it you're splitting the part into essentially 2D layers of a part that you're stacking up in order to have a geometry that can be fed into the printer to be repeated. So if you look at the part that's shown here, if you split that horizontally by whatever your layer thickness is, over and over again, you're going to end up with your slice file. So the slice file has contour, which is tracing the outside of that layer, and then hatch, which fills the inside. And so traditionally, you feed just the slice file into the machine, and then the machine applies the contour laser parameters and the hatch laser parameters to that slice file. So the machine owns effectively the laser parameters and is in charge of the repeatability of your part. Now, when I'm talking laser parameters, I'm talking about how quickly the laser is moving in every direction, and how like distances between when it goes back and forth, the speed, the feed, and the distance and the gaps between the precision movements of that laser. That's what I mean with laser parameters. So when we're talking about repeatability, if you have two machines that are sitting right next to each other of the same make and model, if you take those two machines and you calibrate them, right, to the field service engineer standard, the machines can have their own personality. And so they can be applying slight differences to that slice file to be able to repeat that part and print that part on two different machines. And ultimately, this is not good for machine repeatability or part repeatability and potentially material properties. And so what we do is we take a different approach to that to enable our customers to be able to repeat those parts on machine, serial number 1, 2, 3, 5 at location 5, 6, 7. And the way that we do that is the slice file in this case would be called the Velo print file. That Velo print file contains all of the laser toolpath parameters and laser parameters that you need to repeat that part over and over again. And so the machine itself is not applying your parameters to your part. The part file is dictating exactly what's happening inside the machine every single time. And so because of that, you can go ahead and repeat that part on any machine, any Velo system with the exact same print file. And so this works really well, especially when we're talking like your configuration management. You can rev release that, rev A, rev B, whatever it might be, and then use that at any given point in time to repeat your part without having to go over through that non-recurring expense that we mentioned before over and over again.
So and I'm coming back to this one. I noticed we have the printer, the picture of the printer. We also have this print file, and it's almost like a puzzle piece where you have to keep matching them and almost develop them both and then get them to sync. And then you have to do that again and then again and again. It almost sounds like that's what you're describing.
Yeah, and what I would like to kind of focus on is I'm not saying that you get rid of all NRE with a Velo system. What I'm saying is that if you go down one side of this flowchart and you do development on a Velo system and you pay that NRE to develop your part, you can then take that print file and go to the other side of the flowchart and eliminate that NRE portion for that part, right? Maybe not your process qualification, but for that part, the NRE is effectively eliminated.
Okay, so you can at a lower cost level, and I would assume quicker, get to scale, get to multiple, more of a franchise metal out of manufacturing approach then.
Yep, exactly. So depending on the criticality of the parts that you're printing, so as a simple example, say you're making a doorstop and you're making a jet engine, right? Jet engine's flying people, doorstop does nothing except for hold doors open. The process qualification, kind of what we were alluding to earlier with the Fortune 500 companies, that process qualification is much higher, right? The work that you have to do to ensure that your process is in control is definitely still there. And so when you're unlocking an additional contract manufacturer to make your parts in the Velo world, most companies, if you're making that jet engine whose people's lives are on the line, they're still going to go and qualify a new location and then begin to repeat the parts, right, that they have Velo print files for after that they understand that contract manufacturer has their process in control. But when we're talking a doorstop, you don't care about the process control or the material properties. You just want a dimensionally accurate part. And so you can then repeat that on any Velo system anywhere running the same alloy and expect the same geometry.
Nice. And you mentioned kind of a couple of things. You mentioned the part itself, but then also material properties. And a thought occurred to me, like it's not enough just to print the same shape. You're making the metal while you make this print as well. So that metal could be a different type of metal. It could be a different strength or something.
Exactly. And so when you're looking at the traditional market and everybody running their machine slightly different than the next, the material properties can vary drastically. And if those feeds and speeds of the laser, the toolpath is all different, you have to focus on ensuring that they can meet what your standards might be. And where you draw that line in the sand for what we call witness coupons, what the industry calls witness coupons. Witness coupons are usually coupons that you print in your build at the same time as your part that you can then go test to ensure that your material is coming out the way that you expect it to be. And so these, as an example here, we have some oil and gas choke valves. We've recently had some white papers come out about these, and so I would highly recommend you get a hold of those and read them. But for the quality of part that they're printing here and for the importance and the criticality of this part, they needed to ensure that the material properties are what they expect them to be. So they include these witness coupons that can be tested after heat treat, right? So you have the printing portion, you have the chemistry portion, you have the heat treating. All of that can have a drastic effect on your end state. And so by including those witness coupons, you can then test the material properties in that end state to verify they are what you're looking for.
Okay. And maybe if you could shed a little bit of light on that case study, there are some pretty powerful findings from this study. Like the parts are these cylinder parts. The rest of this metal is basically there for your material properties validation, if I remember right.
Correct. So focusing on the dimensional accuracy of that study that we did, we worked with IMI, right, as you can see in the case study there. And what we did was we printed that exact build that you saw on the screen. We printed that at multiple different locations with the exact same Velo print file, 0 changes made to the print file, at multiple different locations on multiple different sapphires. And then we provided those parts to IMI to do their standard flow testing on. And at the end of the day, what you'll see in that case study is the flow characteristics out of every part that was made met their specifications. And what's really, really fascinating to me is that, the range I think they had, I can't remember exactly, I think it was plus 10%, minus 10% or something like that,
Mm-hmm.
that was acceptable. But in order to exceed that plus or minus 10%, all you had to do was change the length or the width or the height of every flow path by 2 thou, right? So if your machine is slightly off, 2 thou is not very much. And that's so it's 0.002 inches. And if you were oversized by that much on any one of those dimensions, you would essentially not fall in line with what was an acceptable limit of flow through those channels. And I've spoken with some people in the industry, and there's some doubters out there that this was actually that this was performed in the way that it was performed. And I worked on it myself, and
Yep.
this is how it happened.
So just kind of breaking this down visually, coming in here, you've got I guess the left side of this, where you've got the OEM, in this case was IMI, working on initial qualification. Where did they do that initial qualification?
Yeah, that was before actually I hired on, where they did that initial qualification of the part. That might have been at one of our contract manufacturing manufacturers that we work with. But effectively, that initial qualification bucket was done a year before we moved into this production phase, where we made it at all the different locations.
Okay.
And we took that same file from a year before and repeated it 7 times or 5 times or whatever it was.
And that's this print file, and that's what we're calling the golden print file. The title of this episode is this little file here that says print file on it. And then that goes to anywhere we want?
Exactly, right? So as I mentioned earlier, that print file contains all the toolpath necessary to repeat your part. And so if you can go to a Velo printer, running your alloy and repeat that part over and over again. And when I say Velo printer, there is the caveat there that it is of the same size and laser count, right? You can't do an XC to a Sapphire, because you got to assign those 8 lasers on the larger machine to your part.
Yeah, you have to tell the lasers what it could. Now you got 8 instead of 2, right? Yeah.
Exactly.
And so what at each of those contract manufacturing facilities, like what are they doing then? They get the file. I guess they download it. They put it into the printer. What do they have to do to those printers to make sure that they're doing the exact results then?
Each location before they run that file.
Yeah.
Yeah, and it's a couple clicks. They click, and then the machine goes off and calibrates itself using its internal sensors. And then one really nice thing about this is that there is a really easy to read build report that is generated by our Assure quality software that shows these calibrations and when they are performed and if it's in spec. And so it's very, very easy to go and understand. So this is just a quick, what's on the screen here. This is our Assure software. This is just showing that, there are 6 machines and in their various states. But if you click on that little green arrow on any one of those, it goes into more detail as far as what's going on in that printer. And then when the build's done, you can generate the report and see all sorts of really easy to digest information that quality assurance groups and receiving inspection groups are having a much easier time looking at than 10,000 line items of text.
So we have a question here about a data repository. Not exactly sure data, like which data it is, but like in terms of these print files, where would they be stored and how?
Yeah, so the print files themselves would be stored by the OEM essentially, right? So the owner of the part has the ability to store these files and do whatever they need with them as far as shop the contract manufacturing network for lead time and cost. And then as far as the material data for the different process, most of the time customers are going to own that portion themselves. We are doing some work at Velo3D to help our customers essentially get into production faster, and working on various levels of material data to be able to share with our customers, and that is ongoing right now.
Nice. So we do have one good closing thought question. Where do we start to find the hidden markets for repeatable, reliable, print first time capable metal printers? So this is from Kendrick. And I think there are a couple of things there. Is obviously Velo3D supplies printers, but we have a CM network, Maybe you could talk a little bit about the CM network and then also about how to get in touch with Velo in case they do want to build their own facility.
Yeah, so the contract manufacturing network is set up so that our customers can essentially get their feet wet in additive or move into serial production. There's a couple different business models as far as like how you can utilize metal additive, but feel free to reach out to anybody at Velo, especially my group, the business development team, to help kind of bridge that gap as far as like make it nice and easy as far as making the introductions to the contract manufacturing network and getting involved with some the ability to start to build your business case without any obligation. That's one thing that we do focus on, especially my team. We help customers see what that business case might be. The second part of your question, what was
that? If they wanted to own and operate their own system, what would be the steps to doing that?
Yeah, so the owning and operating your own system is going to start with definitely building out that business case and ensuring that it makes sense for you. But then as far as purchasing a machine, installing it, and getting that set up and qualified for your application is something that we can help with, right? We've got a number of people, especially in the business development and technical sales team, who have done this before at multiple locations, including myself, and we're happy to impart serious amounts of information to help smooth that path for you.
Yeah, and Mo, I saw your question at the end. If you're interested in data that'll help you speed up the process to going into additive, I would suggest reaching out to Brent's team. They're really good at sort of answering those specific questions. I don't know, Brent, have you heard my joke? How many engineers does it take to change a light bulb?
I have not.
It depends.
Yeah. Yep. So Mo, whatever your alloy might be that you're mostly interested in, reach out. We may have made some additional progress there that we just haven't shared yet, but we do have some plans of sharing material data under NDA and whatnot with customers to close that barrier.
Yeah, and with that, 30 minutes flies by. I always forget how quickly it goes by. But Brent, do you have any closing thoughts? Any final words for the audience?
Yeah, I mean, if this is something that is of interest to you, as I mentioned, the no obligation, feel free to reach out and we'll look at your geometry and see what that business case looks like, right? Help you compare whether or not it makes sense to print your application, and how the contract manufacturing network can help there. One thing that's been critical right now is lead times. Lead times in the additive manufacturing world, typically in their worst state, is somewhere between 12 and 15 weeks, right? In the worst state. And that's drastically faster than a lot of casting and forging solutions at the moment. In the best case, depending on what your post-processing might be, parts can be made in 2 to 5 weeks, if you have minimal post-processing. But the printing queues are usually not what drives the longest lead time. It's usually the post-processing. So we can help you understand all of those little details as far as how that applies to your application.
Awesome. Well, thank you, Brent. And thank you, everybody, for joining us today for our first 3Din30 of 2023. Definitely more to come. Also, we have a lot of live shows. And if you do have questions and you'd like to sit down with a Velo3D engineer, we're staffing a number of live shows in a number of different industries. So take a look at our webpage, look at our events page. We have that up. We also have a roadshow schedule, which is a great opportunity to come in to a closed environment, have in-depth training on Velo3D technology, have one-on-one interactions with our engineering team and get those questions answered. So plenty of opportunities to learn more in case we didn't get to your questions today. But thank you, everybody, for joining us. And again, Brent, thank you and welcome to 2023.
Thanks, Mike.